Hello and welcome to Prototype and See, a brand new podcast for designers, engineers and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and low-volume production parts. I've been in this industry for nearly 20 years, but I feel there's still a great deal about our customers that I don't yet understand. So, in Prototype and See, I'm going to be sitting down with some of the world's most innovative companies, talking to designers and engineers, all about the successes and failures, the ups and downs of bringing new products to market. And today we're very privileged to have with us Marco Pavan from SteamJet Space Systems. Welcome.
Thank you, James. Okay. Thank you very much for inviting me.
Not at all. Please just give us a quick kind of intro to you and SteamJet and what you guys are doing.
Sure. First of all, thanks again for having me over. I'm Marco Pavan. I'm CEO and co-founder of SteamJet Space Systems. Maybe you can give like a really quick intro about my experience and what brought me to SteamJet.
Please do.
And then a little bit about what is SteamJet about. Just a few things about myself. So I'm originally from Italy, so I graduated in Italy. I have a bachelor and master degree in aerospace engineering. I worked for a couple of years in Italy, then eventually moved to Germany, working for Airbus for a couple of years. And that's because obviously I've been always passionate about space and aerospace. So that was really fitting what I wanted to do. After a couple of years working there, I did a PhD. So Airbus basically asked me to do a PhD in aerospace engineering in Coventry, in UK. So I say, why not? Mm-hmm. And I moved to UK, and towards the end of my PhD, that is actually when SteamJet Space Systems started. So at SteamJet, we design and manufactured propulsion systems for small satellites and CubeSats. CubeSats are, for who doesn't know, who's not really familiar with the space sector, a really, really tiny platform. So you can imagine a satellite which is the size of a shoebox, so really, really, really small one.
Okay.
And at SteamJet, basically, we design propulsion systems specifically for those sort of platforms. And the main innovation for us is that we use just low pressure water as the main propellant. So we don't use chemicals or other toxic propellants. We use the greenest propellant that we can have, which is water. And in principle, what we do is really easy. Obviously, it's a bit more difficult actually doing it. But basically, what we have is sort of a steam engine.
Okay.
So we have a water tank, and we convert the water into superheated steam, so steam at really high temperature, and we just eject that through the nozzle, through a nozzle to create thrust. So that is what is actually creating thrust. That is what actually is moving the satellite.
But that's only used to move the satellite once it's up in space. It isn't.
Yes,
you
that's
can't
correct.
Use that to get it off the ground.
No, you wouldn't be able to do that. But once in space, obviously, you are in microgravity condition. Even really like a tiny thrust of about a few million newtons, which you probably wouldn't even notice here on Earth, that is able to move satellites around once in space.
And how precisely are you able to move?
So pretty precisely. So the thing is that for those tiny platforms, which are weighing even 10, 20 kilograms or less, so really, really tiny one, you just need a little bit of thrust to move them around, you know? And the smaller is the thrust, actually, the better you can control it.
Yeah.
Now, there are other systems like electric propulsion systems. They have a much lower thrust. The negative side of it is that, obviously, if you need to do like a maneuver in space, perhaps change your orbit of about 50, 100 kilometers, it's going to take you like a really long time. So our system is sort of in a sweet spot, because we can be completely safe because we just use water, but also we can move the satellites around pretty quickly compared to electric propulsion systems. And if we compare ourselves with chemical thrusters or thrusters which especially were used on bigger satellites satellites, and they were using like toxic propellants such as hydrazine or other stuff. Well, then we're much greener than that, so we can.
So it's a more environmentally friendly.
Yes, and also,
and that's a concern even when you're out in space.
Yeah, and especially because if you're handling toxic propellants, it is very expensive to do it. And you need to
whilst you're here.
Yes, once you're here on Earth, like just to handle the propellant.
Yeah,
but if you just need to fill something with water. Obviously everybody can do it, and there's no problem around it. And this is extremely important, especially for CubeSats and small satellites, because the cost of the mission is not hundreds of millions like it was 20 years ago for like huge satellites. It's less than $1 million, 500K. So it's much cheaper to do it today. And that's why you don't want to introduce any cost or any complexity on the mission if you don't have to.
And that's the way the market's going, is it, towards these smaller CubeSats?
Yeah, absolutely. Like if you think about like a typical satellite 20 years ago, you would think something which was probably as big as a double-decker bus, was weighing like tons, and it was costing hundreds of millions, and it was taking 5 to 10 years to be developed. And only a few really big companies or government agencies were actually able to do it, because obviously the cost was massive. Well, the same function can be done today by a satellite which is about 10 kilograms in weight. As I say, the size of a shoebox, really tiny. And that is costing probably less than $1 million, and it is taking less than 2 years to be developed. So we've seen like a massive shift towards really tiny platforms which are doing the same thing. Because then if you think about the technology, for instance, if you want to have like perhaps a satellite 20 years ago was taking pictures of the Earth, so Earth observation. The camera was huge. Just think about the camera you have in your phone today. 50 megapixel, and so it's much better than the one that they had 20 years ago, and it's fitting in your mobile phone, so it's really tiny. So the miniaturization of electronics is what really allowed to do this big jump, from really tiny platforms.
And that's making the whole thing more accessible. So you get a lot more different types of companies, customers coming to you to utilize this technology.
Oh yeah, definitely. So before, the entry barrier was huge.
It was just government.
Yeah, it was just government basically going to space. But now, because costs are like 100 times less, with less than $1 million, you can have your own space mission. Which includes also the launch sector. Because obviously, if you need to launch a satellite which is 10 kilograms, it's going to be much less expensive, than launching a satellite which is 1 ton. So there's a lot of new startups which are, joining in the market, and they are finding new ways basically to generate data. And if we look at the data, the most useful data today produced is remote sensing, so like Earth observation, and also telecommunications. There are companies such as Starlink, for instance. We all know about Starlink, SpaceX. They're trying to basically bring internet everywhere in the world, also in the rural areas, and to do that they have a constellations of small satellites. So their satellites are not 2 tons, 3 tons, they're like a couple of 100 kilograms. So really small one. And to just give another few examples, there's OneWeb, UK company, and then there's Spire, Planet Lab, which are more on the remote sensing. But I think also what is really driving the market is the space downstream sectors. So there are more and more companies on the downstream sector which are using that sort of satellite data to create business insights. Like if you think about tracking for ships, planes, cars, they can use data taken from satellites, pictures, and they can use artificial intelligence, machine learning, basically to create business inside out of it. So for a store, for instance, they can understand how many cars they have parked on their parking lot, and see how is that changing with time. And on the humanitarian sector, I think one of the use cases which is extremely useful in driving the sector is also the disaster recovery. Because obviously we've all seen what happened in Syria with the big earthquake. So there was actually satellite data was able to show perhaps the areas which were most impacted by the earthquake.
Okay.
So they could develop plans basically to help people in those areas.
Right. Very
it's been
quickly.
it's been really, really useful from that point of view.
Okay. I mean, that's fantastic to hear that those things are going on. And you say there's quite a lot of new startups coming out at the minute, and I hear good things about the space industry in the UK. Is it a good place to be an aerospace startup?
Yeah, I think it is. I can tell you, for instance, our personal experience. So one thing that we have seen since we started is like a big support from the government. So there are organizations such as Catapult, Satellite Application, and then there are a lot of a lot of ways basically that UK Space Agency or the government can provide funding to small startups from the early stages, so where from you first have like the first idea to then as you progress and you start to have some traction. So I think there's a lot of funding from the government, and also because the government has a really ambitious plan, I think, to really be part of the space sector in the next 5 to 10 years.
Okay.
And for us, for instance, when we started, we've been in business incubation center, which is in Westcott. That really helped us to define our business proposition and help us with a few grants to create some initial prototypes. So I think it is a really good ecosystem, and as we were talking before the starting of the interview, there is like a really, really big cluster of space companies in Harwell.
Right.
Which is also where ESA is located, and many other like UK startups operating in the space sectors are located. Okay. So even if you just go there for a networking event, I would suggest anybody in the space sector to go to the Satochino event, which is every month, and you get like a free cappuccino, and you can network basically with people working in the space sector.
Okay.
And you always find someone interesting to talk with, and someone that might help you with funding, or potentially collaborations to do something else. So it's a really vibrant ecosystem. So I think it's a great place to be for startups in the space sector.
What about obviously we had the recent failure to launch from
Virgin Orbit.
Yeah. How is that going to affect the industry in the UK? Is that?
Well, I don't think like for startups like ourselves, for instance, is really going to massively affect that. I mean, it's been I think obviously quite bad for Virgin Orbit itself. Because we've seen how all the problems they're having now. And eventually the plan is to really have a spaceport in UK. Like use like some sort of airports, facilities that were already there, like using for space applications. So the idea is obviously very good. And in the future, I'm sure that eventually this will be another way to launch, because one of the things that we're seeing today is that there is an increased demand in launching services. So more and more companies, they want to launch into space, even because, as I say, like it's much cheaper now to do it,
Yeah. And your technology is enabling it to be even cheaper.
Yes, I mean, for us, like obviously our technology will be mostly used in space, but like one use case of using a propulsion system once you are in orbit is that you don't really care about the orbit where you are dropped off from the launcher, because then you have your propulsion system and you can just go wherever you need to go. So that is a main use case for having propulsion on board of your mission. So our technology is enabling that. And also, if we look ahead in the future, because we use just water, there are already ways they're trying basically to do some sort of refueling on orbit.
Right. Okay. Yeah.
And potentially,
I was just about to ask that. Yeah. Does it run out? Like.
Yeah, it does.
Yeah,
all propellants, it does.
How long? Like, conceivably?
Well, I can give you an example. the amount of water that we see on this glass, maybe just slightly less than that, is enough to do probably 100 kilometers change in your orbit.
Right.
So you don't really need like a lot of water
to
actually do an orbital change.
Okay.
And but eventually, yes, it will run out. So.
And what happens then? At the
minute, you just you decide the amount of water. You plan it before, of course. Yeah. So you need to do that in your mission, which could be, as I said, like an orbital change. Perhaps if you have a constellation, you just want to do station keeping. So because in a constellation, you need to make sure every satellite is communicating with the other satellites. So you need to do a lot of small adjustments, and then perhaps you wanna do the orbiting at the end of the mission to avoid all the space junks that we have already in orbit. So you plan how much water you need to do all that, and then eventually that your mission is going to be 5 years, and that allows you to calculate how much water to carry, and you just carry that much water.
Okay.
One of our product, which is the Steam Thruster 1, has the possibility to bring as much water as you need. So we can just customize our water tanks in order to fit the amount of water which is needed for your mission.
Okay. And so when you build your product, you're building it like to order almost.
Yeah.
Right?
So
depending on the customer's requirements, how long they're going to be up there, what they're going to be doing.
Yes.
You would then design
system. Yeah. You try to standardize in a way. Yeah. Also, obviously, you want to reduce the amount of customization in a way, but then also customization is still really important.
Yeah.
And one of the things that we can do, compare, for instance, to even bigger companies which are in the market, is really the possibility to customize the design, because we use a lot of additive manufacturing in our system, and basically 3D printing. And what we can do with that, we can achieve a really high freedom of design. So we can even change the shape of our water tanks in order to make it better when you actually integrate that into the satellite. And integration is really important because everything you put on your satellite is gonna slightly move your center of gravity. So you wanna make sure that when you put everything together, and also during the mission, your center of gravity is not moving too much. And one way to guarantee that is also if you can perhaps create like a sort of a personalized or customized shape for the water tank, so that it can better be integrated.
And does your technology like free you up in terms of the types of materials you can use, because you're not dealing with like toxic chemicals and things like that?
Yeah, I think for most of our propulsion systems we use titanium TI64.
Just for the weight saving.
Yeah, just because it's obviously slightly lighter, and it's also quite resistant. So potentially we could use other different materials. We actually investigating that. So the key innovation for us is the way we convert water into steam. So that is the key innovation for us, because we can do that with a really compact design of our heat exchanger, and using very little power. So obviously there's a lot of research about which materials you want to use on that, because the difficulty is to be able to create like a core which is really hot, because you want to convert like water into steam, but you don't want to transfer that heat to the rest of the system and to the satellite. So that's why the choice of different materials in that case is important, because you want to minimize then the heat transfer to the satellite. Okay.
Do you use a lot of generative design in?
I would say we try to keep it simple in a way. So we have a quite simple design.
I mean, it is a cube for all intents and purposes.
Yeah, exactly. And as I said, we can customize that. In case
there's a lot going on inside, I'm sure.
Oh yes, inside is all minimized. In terms of we just remove as much material as we can to make it lighter, but also provide enough strength to survive the vibrations, basically to survive launch, because that is when your system is really, that's where you have most of the solicitation. So that's where you have most of your vibrations, and that is where it's more difficult for the system to survive. Once it's in orbit, it's easy.
How long does it take you to build one? Right.
What do you mean, like designing it, like or just like manufacturing,
putting it together?
So at the moment, probably, so the 3D printing process is not going to take long, maybe like a week, and then the assembly, it takes a little bit more time. So obviously, it depends also how many we have to build. So the system itself could be built in less than a month. We do have a lead time which is a bit more than that, because obviously we have other orders to fulfill and other things. But the assembly procedure as well is not too complex. So it's something that we are trying to improve also. Every iteration we do, we try to improve it. For us, I think the most challenging bit for us has been really to increase the TRL level of the system from like really like a prototype lab, which was just tested, but we not really tested in space, let's say, to the actual space prototype. So that's why I say every time we do like an iteration on our design, then things get better, like, and we improve the performance, and also the assembly time reduces. So with time, eventually we're going to shorten this more, but at the moment it's still there's still quite a lot of experience involved, and like sort of manual process in the assembly.
How many like individual different parts are in there? Do you know? Is it like hundreds, thousands?
Yeah, it's not thousands. Like it's still like we try, as I say, to keep it simple, and the reason why we choose also 3D printing is that we can basically build a single part, So instead of building, 20 different parts using traditional CNC machining or these sort of things, we can produce one single part, and obviously the assembly at that point would be much easier. We still do some post-processing, obviously, after manufacturing, because we need to get the roughness done, and we need to make sure we are within the dimensions that we want to be,
Does it? Yeah. Okay. So what's the future plans for you guys? Like.
That's a good question. So at the moment, as I said, we have two main products, which is the tuna can thruster and the.
Why tuna can?
Well, because so the way CubeSats, which are these tiny platforms, are just, let's say, dropped into the final bit of the orbit, is through this through like a container. You put this CubeSat inside this container, and this container has a spring located inside.
Right.
That spring is what is actually pushing the satellite out.
Okay.
All right. So that spring is basically is occupying a volume. Because it's a preloaded spring, and that volume is called tuna can volume.
Right.
So I don't know, or I don't know why it's called tuna can, because maybe it looks like a tuna can.
It looks like
eventually. But so that is some volume which is not really used by the satellite.
Okay.
So we developed something that can fit into that volume. Now the main benefit of doing that is that volume is not inside the satellite. It is outside, actually.
Right.
So basically, if you have really, really tiny CubeSat, you can still use the whole volume inside for your payload, for the things that matter. And then you can still use propulsion system because it's installed outside.
Right.
So, we take, we use that volume to provide something, beneficial for the final customer. So to have more volume inside the satellite itself.
Okay. All right. So that's why tuna can. And you were going to tell us like what the future holds.
Yes.
For you guys.
Yes. So as I say, at the moment we have these two main products, but we know that we would like to develop new things. One of these, for instance, is an attitude control thruster. So at the moment, always using like our technology, which is the main innovation for us. But at the moment, we can provide just thrust along one direction. You know, as I say, perhaps to change your orbit, increase or decrease your orbit. But one thing which is, extremely, it's quite important and requested, needed from the market is the possibility to change attitude. So just to, rotate basically your satellite around. So we're working at a solution even for bigger satellites that can still use our technology, but provide also this capability so that you can use our propulsion system not just to change your orbit, but also to rotate it around, basically, to provide also attitude control. And one other thing that we are now studying is new versions of our propulsion systems with much higher ISP. By ISP, I mean the specific impulse. So it basically is how efficient is your thruster. Now, if we use our propulsion system for small satellites up to 100, 200 kilograms, then we can fulfill the needs for the mission. But if we're talking about really, really big satellites, then it's not efficient enough in a way. So that's why we need to work at perhaps different technologies to produce that steam in a way that is much more efficient, so that we can use it not just for small satellites and CubeSats, but also for bigger satellites, over 500, 600 kilograms, a ton, and so on, which is still a big market. We believe the sweet spot at the moment is around 200 kilograms. So a lot of the constellations that we see coming are around that mass. But still, we see a lot of missions, especially deep space missions, which need a more, let's say, a more efficient propulsion system. And if we look even further ahead, perhaps at asteroid mining, for instance, there will be the possibility to extract minerals from asteroids in the future, and water will be one of the easiest thing to actually extract from asteroids. And therefore, with a more efficient system, we could enable more interplanar missions or deep space exploration, because you could refill it
That's exciting.
on the go, Obviously, this is more sci-fi talking, probably, but that is the direction that we're working
soon to be reality.
Hopefully, yes.
Any advice for new startups in the aerospace industry?
Yes. So I think, if you have a good idea about anything related to space, which could be upstream for like a subsystem, or downstream for, as I say, how to actually process data for coming from satellite, I think my advice would be to pitch that idea to perhaps business incubators or business accelerators. So there are many of them. As I mentioned, the Westcott Business Incubation Center, but there are much more. There are many more, let's say, in the country. So I think, initially you can really get a lot of support, because initially you might have a good idea, but perhaps you don't have the skills, or you don't really know how to create like a proper business proposition out of that. So
how well are these incubators able to understand the ideas behind?
Well, that is up to you. How well you can explain it in a way.
I guess so.
But
I guess so.
Being out of the sector, they definitely be able to help you to formulate that in a better way. You might have just like an idea, like maybe vague idea about something. So they might help you also with the market research, because obviously you need to make sure that that idea can have a potential market. The space sector is a niche market, so obviously you don't expect to deploy something that everybody is gonna use, on the planet. But they can help you to identify perhaps that small part of the market, which is good enough initially to attract some investments, or just to get you started at the end. So I think that is the best thing I would suggest for new startups. Like try to go through these incubators, accelerators, and try to pitch your idea, even if you're not going to be accepted. At least you will have prepared something, and that that itself basically would have given you the opportunity to improve the way you talk about the idea. So it would be anyway some sort of a useful exercise for you to better formulate the idea, and then eventually they will support you with the other steps. So once you have perhaps some initial funding and you can do perhaps a prototype, if you need to manufacture something, then you can use that and their connection to attract investments and then to support you perhaps towards there are a lot of programs perhaps that are giving you the opportunity perhaps to test your system in space. Access to space is still expensive. It's not that expensive as it was 20 years ago, but still we're talking about, 100 to 200k or even more. So if you are like a startup, you don't initially have that amount of cash. They might support you through free launches, free in-orbit demonstrations launches. UK Space Agency is doing that, and also catapult satellite applications. So they can help you with a lot of things. So my suggestion, perhaps start with going to the Satuccino event, as I was saying, the one in Arwell. You go there and you just start talking with the people which are going to those events, and something will come up out of that.
Okay. Thank you very much.
You're welcome.
Very much, Marco Pavan, SteamJet Space Systems. If you want to learn more about you and your company, where's the best place to do that?
So you can visit our website, SteamJet.space. You can connect to LinkedIn, and or you can drop me an email. My email address is marcopavan@steamjet.space.
Okay, thank you. I hope you all found that very interesting. I certainly did. Don't forget to like, follow, subscribe, whatever you have to do to make sure you don't miss the next episode of Prototype and See. Thank you. Bye-bye.
Thank you. Bye.
All right. Yeah, there you go. Is that okay?
Yeah, that's good.
Thank you very much. Whether you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.